So example 4, the USA Today ad track, this is several years ago, back in 2000, examined the effectiveness of the new ads involving the Pets.com sock puppet, now extinct. In particular, they conducted a nationwide poll of 428 adults who had seen the Pets.com ad and asked for their opinion. They found 36% of the respondents said they liked the ads. So part A, if you wanted to cut the margin of error in half the next time you took a poll like this, what sample size would you need? And there's a multiple choice. So one that's twice the size it was before, half the size, or quarter the size, or quadruple the size of what it was before. And then part B, use the results of this poll to make an estimate for the population of all viewers of the Pets.com sock puppet ads. And what proportion of the population do you think would have liked the ads? Give the most complete answer using statistics. Okay, let's look at part A. So let's think about this. So recall the margin of error. ME is Z star, the critical value, times the standard error, which is the square root p hat times 1 minus p hat all over n. So again, in general, point estimate plus or minus margin of error. If we assumed a 95% confidence level, we'd have a Z star of 1.96. We plug that in, we're going to get a margin of error of 0.0455. So this is for our current example. This is what the margin of error is. And the problem asked, how can we cut this margin of error in half? Now, there are only two numbers we can control, the confidence level and the number sample. So notice that none of the choices deal with the confidence level. We can ignore that one for this particular problem. So I want you to know, though, that the confidence level does affect the margin of error, right? We saw that when we went from a 95% to a 99% earlier. Let's investigate the number sampled. So what would happen if I doubled it? So when I double n, I'm dividing by 856 instead of 428. Does my margin of error get cut in half from 0.0455 to 0.0322? No, that's not cut in half. Let's double it again, which would basically be quadrupling the original one to 1712. Yes, that's it. So 0.0227 is half of 0.0455. Again, there may be a slight rounding error there. And this sort of should make sense, right? Because we're taking the square root of the number in the denominator. So the answer is D. So part B asks us to estimate the proportion of all viewers based on this sample. So creating a confidence interval is just one step away. We've been doing this. We found a margin of error. Again, it's point estimate plus or minus margin of error. We found a point estimate of 0.36. So 0.36 plus or minus 0.0455. And this can be interpreted as we're 95% confident the true proportion of viewers who like the Pets.com sock puppet ad is between 31.5% and 40.6%. Another way to look at that, we're 95% confident that between 31.5% and 40.6% of viewers like the Pets.com sock puppet ad. Example 5. Suppose in our last example we wanted the margin of error to be less than 2 percentage points. How large would the sample size need to be if we wanted to keep the 95% confidence interval? So recall the formula we used to construct a confidence interval about a proportion. It's given in the form point estimate plus or minus the margin of error. And there's that margin of error term to the right of the plus minus. So our margin of error, we can write that as ME is the critical value Z star times the square root of p hat times 1 minus p hat all over n. Let's write this as an inequality, as we want this margin of error to be less than whatever the margin of error we specify. So I want you to note we have a little problem here, don't we? Recall what we're trying to do. Our formula requires us to have p hat, the sample proportion, before we actually take the sample. So we have two options. Use a sample proportion from a prior survey to estimate p hat, or 2, use p hat equals 0.5. This will give us the largest margin of error. We can use some algebra here to solve for n to get n by itself. Now you may also see the two square terms aligned together like this. So again, the one on the left is n is greater than or equal to z star squared times p hat times 1 minus p hat all over the margin of error squared. Or I've seen it written as n has to be greater than or equal to the quantity z star over margin of error squared times p hat times 1 minus p hat. I generally prefer the first one, so I already know the one from the confidence intervals. I don't want to have to memorize another formula. I just want to take the margin of error term and I can just plug in and solve for n as I need to. So let's go ahead and use our formula here to answer this problem. So let's label what we know. We know the margin of error is 2 percentage points, so we'll write that as 0.02. We want 95% confidence interval, so it's Z star. The critical value is 1.96. And we can use our earlier poll and estimate p hat at 0.36. We're going to substitute these values in and solve for n. So if we square both sides, we're going to get 0.0004 greater than or equal to 3.8416 times 0.36 times 1 minus 0.36 all over n. Now let's multiply both sides by n, and then go ahead in the same step, we'll divide through by 0.0004. We're going to get n is greater than or equal to 3.8416 times 0.36 times 0.64, all divided by 0.0004. We put this into the calculator, and we're going to get 2,212.8. And we always round up. Even if that were a 0.3, we round up to the next whole unit. And we're going to get an n of 2213. So we could have used the formula where we were already solved for n. Doing exactly the same way. We have n. I'm going to use 1n greater than or equal to z star over the margin of error, all that squared, times p hat times 1 minus p hat. We label as we did before. ME is 0.02, Z star is 1.96, P hat is 0.36. We plug everything in. It comes out exactly the same at 2213. So computationally, this is easier by far. We've already solved for n. We've already sort of done the algebra part, right? It's sort of a plug and chug. However, this is another one I have to memorize, which I don't want to do. So again, normally I go with the first one, unless if you're not taking the AP and you're allowed a note card, maybe you want to put this on your note card on an exam. But on the AP, this formula is not given.